Hello, it's Michelle Hobbs. I'm doing the practice exam part 2. Let me go ahead and share my screen. Oops. All right. Excuse me. All right, and I have some notes, and I'm also working with the screen here and everything you have provided for us. So, what is the definition of a point estimate? Let's open this up.
Before we build the confidence interval for population proportion, we need some basic definitions. The very first definition that you need is the definition of the point estimate. Well, a point estimate is a single value is the population parameter. Proportion and
Okay, so a point estimate is a single value that estimates the population parameter. A point estimate is a single value estimate for a population parameter. Next. What is the point estimate for population proportion?
we try to estimate population proportion. Here you have a population. The proportion of population is denoted by P. When you take a sample from that population, the sample proportion is denoted by P hat. Or population proportion P the point estimate is denoted by P hat, as I mentioned here, which is the proportion of successes in a sample. How do we
Okay, so population proportion, the point estimate is the proportion of successes in a sample. The point estimate is denoted by, which is the proportion in a sample. So a sample proportion. Yes. Okay. What is the point estimate for population mean? I'm assuming we'll keep going with this video.
P hat is defined as X over N. What is X? X is the number of successes and N is the sample size. Very good. So let us take a look at a quick example. In this example, you ran a survey. In a survey of 1,000 US students, 375 said they own a smartphone. Very good. Now, what is P hat? What is the proportion of success in this sample? Find P hat. Well, P hat sometimes is given as a percentage to us because
it's going into another sample problem, but the point estimate for a population mean is going to be the sample mean. Just like the population proportion was a sample proportion. So sample mean, population mean. That's how I remember it. Okay. Oops. Excuse me. Okay, and then this is going into the example here.
you don't have to use this formula. Some other times you have to follow the formula and actually calculate P hat. P hat is X divided by N, but what is X? The number of successes in a survey. How many own a smartphone? 375 divided by the sample size, or N, is 1,000. Okay.
Okay. So the sample size is 1,000, as just stated.
So P hat can be written as 0.375, or P hat is 37.5%. What's the meaning of that? It means that, hey, you have a huge population of US students, all right? So here you have a population of US students, which is a very huge population. We just took a small sample, 1,000 of them. Now, in 1,000, 375 said, hey, we own a smartphone. So P hat is 37.5%. It means that 37.5% of US students own a smartphone.
Okay, so the P hat is the point estimate. So that is the point estimate is 0.375. The number of successes in the story is 375. And let's see, sample mean or sample proportion.
Follow the formula and actually calculate P hat. P hat is X divided by N, but what is X? The number of successes in a survey. How many own a smartphone?
Number of successes, yes.
375 divided by the sample size, or N,
The
is
sample
1,000.
size is 1,000.
Okay, so p hat can be written as 0.375, or p hat is 37.5%. What's the meaning of that? It means that, hey, you have a huge population of US students, all right?
Oh, type sample
Okay, you
mean
have
or sample
population of
proportion.
US students, which is a very huge population, in a town, 37.5% of US students own a smartphone. Well, I expect you to ask, what if we have a different survey? Are we going to get the exact same percent? That's where we're going to talk about the confidence interval. We're going to take all of those possible percentages and list them in a.
Oh, so this is a number of successes, sample size, sample mean, or sample proportion.
In this example, you ran a survey. In a survey of,
I believe this is sample
1,000 US students, 375 said they own a smartphone. Very good. Now, what is p hat? What is the proportion of success in this sample?
Yeah, sample proportion.
Find p hat. Well, p hat sometimes is given as a percentage to us. We don't have to use this formula. Some other times we have to follow the formula and actually calculate p hat. P hat is 1. So, Steve, are we going
All
to
right,
get
and the
the
next part of this is going to be constructing a confidence interval. So let's see how to do that.
So in this example, suppose you're interested in knowing, well, what's the percentage of US teenagers who own smartphones? What are you going to do? As a statistician, you're going to run survey. You run a survey, and the number of people who participated in that survey, you have 1,000 of them. And 372 said, yes, I own smartphone. What the very first step are the steps that we're going to take in building a new confidence interval. So let's see. Let's have the that you're going to take.
95% confidence
Start
interval.
this step by step.
95% confidence. Construct a confidence interval for a population proportion of teens who own smartphones. It looks like this is the whole breakdown here. So the confidence level is going to be 0.95 for the 95%. And then to find the critical value using the calculator. So to find the critical value, you're going to use NV norm, because look at critical value here, NV norm. Whoops. And then what is the critical value? 1.96, it looks like. 1.96. And then the margin of error is 0.17. And then the lower bound of the confidence interval. The lower bound of the confidence interval is lower bound. All right, let me come back to that. With 95% confidence, you can say the blah, blah, blah population mean or population proportion. It's going to be population proportion. Oops. Population proportion. Population proportion. And then, so the lower is, I gotta find that. I feel like the lower is here, and this is the upper 0.07 and 0.41. Let me just make sure.
What are the steps that have this step on? Called CI, statistician here, you smart and 300%. 0.372 or 37.2%. Your point estimate can be written as decimal, or you can, what should I use? What is the value that I'm going to use if it's not given? What is your CI? Very good. Thank you, everyone. The CI is 95%.
Oh, wait, did I do that wrong?
The confidence interval. So
confidence interval.
let's have these steps. You have to follow these steps. We don't have any other choices, but our question is now different. Our question says, hey, find the confidence interval. Build the confidence interval for construct a confidence interval, CI confidence interval for US teams. Good, which is 37.2%. 0.372 or the confidence level. Do we have any information about confidence level? Do you know what confidence level is? Any idea about that? If it's not given, what should I use? What is the value that I'm going to use if it's not given? Or in percentage, 95%. Okay. We are done with step 1. We're done with step 2. Thank you, Chloe. Thank you, Vic. And now we move on to inverse norm. And this
okay, I did all that correctly.
0.025 mean
wait a minute.
divided by 2. Thank you very much. So the area, as usual, is 1 minus C divided by 2. So C is 95%. 1 minus 95% divided by 2, or the area is 5% over 2, or 0.025. 0.025. Mean is 0, standard deviation is 1. I already know that because I'm dealing with Z. Mean is 0, standard deviation is 1. So let's do the calculation. I already have Christy writing the answer for us. 1.96. Thank you very much. ZC is 1.96. I found my critical value. I'm using my critical value in step 4 to find the times this. I have
You did all this part already.
0.72 divided by n. N is 1,000. There are 1,000 people in my survey. Okay. If I do the computation, E is approximately is what number? Guys, please do the computation and give me your margin of error. What would be the margin of error in this case? What is the calculator? What is it that the class added exactly 0.3%? Remember that. This is the distance. This is your point estimate, and this is the distance. So the confidence interval is equal to, let us open the parenthesis, p hat minus margin of error, comma p hat plus the margin of error. So again, these are all approximations. So it's going to be p hat, which is 0.372 minus the margin of error, 0.0. This interval is about 34.2%, 0.342 and 0.402, or in our final report to the boss, they're going to say that, hey, we are 95% confident what? Confident that the population proportion, the population percentage, the percentage of US teams, the percentage of US teams who
Population proportion.
Smartphones is between 34.2% to 40.
Yeah, so that's the lowest.
So
yeah, so the lowest lower bound is of the confidence interval is 0.342, and then the upper is 0.402. All right. Let's see.
So in this example, suppose you're interested in knowing, well, what's the percentage of US teenagers who own smartphones? What are you going to do? As a statistician, you're going to run survey. You run a survey, and the number of people who participated in that survey, you have 1,000 of them. And 372 said, yes, I own smartphone. Well, if I ask you to find a confidence interval for population proportion, what is the percentage of US teenagers who own, a question says, hey, find the confidence interval, build the confidence interval for construct a confidence interval. Okay, very good. We are the statistician here in this rule. In the very first step, we're going to find the point estimate, which is the sample proportion. What we did, we surveyed 1,000.
Okay, so for this one, we are surveying 64,396.
372 of them said yes.
674 males. Sorry, 674.
So it helps us.
396 say they have gone to the dentist.
Is defined as x over n, the number of successes, which is the number of people who said yes, divided by n, 372.
Okay, so for this one, it's going to be the successes. So that is going to be 396. 396. And then so we're figuring out the point estimate. Yeah, sample proportion. So that'll be 396.
Over 1,000, which is going to be 12.372, or you can write it in percent form, which is 37.2%.
Doing this in my calculator real quick. So it's gonna be 396 divided by, oops, divided by, in a survey of 674 US males. Um, okay, so let me see. In a survey of 674 US males aged 18 to 64, 396 say they have gone to the dentist in the past year to construct to construct a 95% confidence interval for the population proportion. The Hmm. Okay. So sample size 674, number of males who went to the dentist is the success 396. So you're going to do 396 over 674, which is going to be 396 divided by 674 is about 58, 7, blah, blah, blah. It's a long number. So probably point, I want to get this wrong, 0.5875. So point, do I round up or down? 0.8. Okay. Let's see. So what is the level of confidence? What is the level of confidence and the critical value? Oh yeah, the confidence level is we get that from the percentage up there, so it's 0.95. And then to calculate the critical value, we're going to calculate. So the critical value is about 1.96. And then what is the margin of error? Um, Getting a long number here, margin of error. So I'm going to do point 0 B. I don't know. Okay, so then what is the lower bound of the confidence interval and what is the upper bound of the confidence interval? Let's see.
0.372 or 37.2%. Your point estimate can be written as decimal, or you can represent it in percentage. But remember that in the rest of the calculation, very good. Thank you, everyone. To norm is 1 minus 1.96. Thank you very much. ZC is 1.96. I found my critical value. I'm using my critical value in step 4 to find the margin of error. Margin of error for the population proportion has a different formula. E is equal to ZC, which is 0.372. And I can find 1 minus P hat. ZC, I already found it, 1.96. I have everything that I need. Very well. So this time is equal to ZC 1.96 times square root of P hat 0.372 parenthesis 1 minus 0.372 divided by N. N is 1,000. There are 1,000 people in my survey. Okay. If I do the computation, E is approximately is what number? Guys, please do the computation and give me your margin of error. What would be the margin of error in this case? What is E?
So 1.96. So the successes. Point 396. 0.396 times 1 minus 0.396 divided by.
If you just run the numbers in your calculator, what is it that you're getting? Very good. Thank you, Aaron. The rest of the class, Abby, thank you very much. The margin of error is approximately 0.03, approximately 3%. The distance is approximately 3%. 3%. Remember that. This is the distance. This is your point estimate, and this is the distance. So the confidence interval is equal to, let us open the parenthesis, p hat minus margin of error, comma p hat plus the margin of error. So again, these are all approximations. So it's going to be p hat, which is 0.372 minus the margin of error, 0.03, comma 0.372 plus the margin of error, the distance. So approximately what are we going to have? Our confidence interval is about 34.2%, 0.342 and 0.4024. In our final report to the boss, the percentage of US owned smart cent. So this is our very last stop. When you are writing a statistical analysis, you must have a conclusion issue.
Okay, economics researchers collecting data about grocery store employees in a county. The data list below represents a random sample of the number of hours they work by 40 employees.
There we go. So we're going to talk about confidence intervals for population mean. Yes, is working on population mean. When you're constructing confidence interval for population parameter, on mean percent, you have a correct. Remember that. A volunteer from group 4, please read the example for us.
Is it the finding a point estimate?
Correct.
Okay. Okay, and economics research. Oh, research is.
You collected the data, and these are the numbers that you want to use to find to our 9.6 hours. Okay, very good. But it's not exactly the same as your population mean hours. What should I do? I need to go to next step. It's not given to us. So 3 hours, and we're going to do something for the area, have to enter something for the mean and the standard deviation. Take a look at the board. And do the count 6 if you want, and calculate the margin of error. Step 4. Calculate the margin of error. 7.9 hours. The sample size that you used was 40. Let's go back to the question. Take a look at the question.
So the sample
Here,
size is
how many?
40 because there are 40 employees.
From several grocery stores. So N, or the sample size, is 40. And assume the population standard deviation is also given to you as 7.9 hours. Okay, let's enter these. 7.9 divided by square root of it is given to calculate ZC. So Z in the population mean and the sample mean, which is denoted by E equals to Z sub C
29.6.
times sigma divided by
The
square
point
root
estimate.
of N. Very good. ZC point sam 2 is confident Excel and accurate. The very first one is electron L2, L25%, 32 hours. See, they are the same. So it means that the calculations that they did match the calculation that calculator did for us. So it means that we are happy, we have a great confidence interval. But as you can see, your calculator doesn't give you the margin of error.
And then this is for a sample mean. Okay, assume use the data in the previous question to construct a 95% confidence interval for the mean number of hours worked by grocery store employees. Assume the population standard deviation is 7.9 hours. The point estimate is again 29.6. The level of confidence is 0.95. The critical value is 1.96. Yes, CC 1.96. And then the margin of error is 2.4. The lower bound is
7.2. So this is your interval. The mu is population mean. Population. Remember that we do not have the population mean. That's why we took a sample. We found the mean of the sample, and then we used 95. Final answer is correct. So let me put the calculator here for you. Let's turn on the calculator. So use your calculator. Well, it's not very hard. You're going to, so confidence interval using calculator. And so we are finding, well, one, remember that 0.95. It's a common mistake. Students forget to put the on the calculator and the one that they did on the board match. So 27.2 and 32. So the confidence interval using the calculator is 27.2 hours, comma, 32 hours. See, they are
27.2 and 32. So 27.2 for the lower, and the upper was 32, just 32. 32.048, so maybe I'll do 32.0. And then this is going to be,
so it means that the calculations that they did match
the population mean. Whoops. Population mean.
So what is the minimum sample size? Let's take a look at this example here. Suppose we have a researcher, an econ researcher
Oh, excuse me.
wants to estimate of hours. Very good.
Work
How
by
many
all grocery store
employees
employees
is
in the
the question
county.
we're going to answer?
So how many employees must be included in the sample
How
to
many
be
employees
95% confident?
is very standard. Deviation, margin of error for Newton as 65%, 1 point. Yes, it is given to margin of error is 1.5. Compute this quantity of, we get 107 grocery store employees. So the sample size, the number of people that you need to ask is 107 employees. That's how we find the sample size.
107. Okay. Random sample of 60 refrigerators. The mean repair was 150. Assume the population standard deviation is 1550. Construct a 99% confidence interval for the population mean repair cost. Interpret the results. Oops. %99% for a population mean. Margin of error. This would be the most similar.
So this question says, build a confidence interval for population bar. This, well, we need to follow these important sample size. In the next step, we need to find the sample statistic and an X bar. Luckily for us, in this question, X bar responds to the given type. Take a look. You can see X bar is a sigma, and from A plus the population mean is bounded between 12 and 12.6. If we change the confidence level, we get a different confidence interval. So that's why it's important to use a correct critical value.
So the point estimate. Okay, I'm going to try to calculate this one on my own. In a random sample of 60 refrigerators, the mean repair cost was $150. Assume the population standard deviation is $15.50. Construct a 99% confidence interval for the population mean repair cost. Interpret the results. Construct a 99% confidence interval for the population mean replacement cost. Okay, so let's see. So we know the sample size is 60. Um, and the sample mean repair cost is 150. And then, oh, excuse me. Standard deviation, yes, we got all that. Level of confidence, critical value. So the margin of error is going to be the 1550 over 60, which is going to be 1550 2.576. So the margin of error is about, where is it? 5.15 for that one. And then the point estimate is the what is the point estimate and the level of confidence? Mm. So the point estimate should be the 150 after looking at my notes here, and then the level of confidence is the 99, so it's 0.99. And then the lower bound should be 144.85, and then 155.15. You can say that the population mean, and then the critical value. What is the critical value? The critical value is going to be what is the critical value? It's going to be 2.576. Okay, hopefully those are all correct. Okay, I'm going to stop sharing as I review my results. And thank you.